guys, welcome to Everything Blockchain. Blockchain technology is evolving fast, and at the core of this transformation are the engines that made dApps possible, the virtual machines. Today we are putting two titans head to head, the Ethereum Virtual Machine and the Solana Virtual Machine. We'll start with the EVM that's responsible for processing smart contracts on Ethereum. Think of it as the engine that powers decentralized apps, handling everything from simple transactions to complex financial applications. But here's the catch. EVM processes transactions in a sequential, single-threaded manner. Imagine a long line where each transaction waits for its turn. Every time a smart contract modifies data, the EVM processes that contract by itself and then moves on to the next one. So if two contracts need to modify the same data, the EVM has to deal with them one after the other, causing bottlenecks, especially during times of heavy use. It's reliable, but it's not the fastest. This is why Ethereum sometimes experiences higher fees and slower transaction times during peak demand. Now let's switch gears to the Solana Virtual Machine. Solana approaches smart contracts differently by focusing on speed and parallelism. With the SVM, transactions can be processed simultaneously using something called C-level. Okay, think of C-level as a highway with multiple lanes where different transactions can run side by side as long as they don't need the same data. This is what is known as parallel processing. While the EVM processes contracts one at a time, the SVM handles thousands of transactions at once, maximizing the use of the system's hardware. Here's how it works. Before a transaction is processed, it must specify exactly what data it will access or modify. This organization allows the SVM to safely run multiple transactions at the same time, avoiding conflicts where two transactions would try to change the same data. This parallel processing is powered by C-level. It is what gives Solana its incredibly high throughput, processing thousands of transactions per second with minimal fees. But with great speed comes a challenge: managing stability and preventing errors during parallel execution. This requires sophisticated techniques to avoid conflicts and ensure the system runs smoothly. So how do these two virtual machines stack up? Well, the EVM is reliable with a vast ecosystem of dApps built using Solidity, which is a popular and accessible programming language. It operates in a single-threaded environment, which can lead to congestion and higher fees, but its simplicity and security are its strong points. The SVM, on the other hand, takes advantage of multi-threading and parallel processing. It's faster, capable of processing thousands of transactions at once with lower fees due to localized fee markets. However, it uses the Rust programming language, which, while powerful, can be difficult to learn. I also want to mention another point. The EVM single-threaded design, like I said, contributes to network congestion and higher transaction fees. And this is evident in Ethereum's global fee markets, where unrelated transactions can also drive up costs for one another. Whereas SVM's architecture supports localized fee markets, assigning fees per smart contract rather than globally. This, combined with SVM's ability to process transactions in parallel, results in lower fees and faster processing times. In short, to oversimplify and to provide you with an analogy, the EVM is like a traditional library. Each book or transaction is handled one at a time, and the SVM is more like a high-speed food chain where multiple orders are processed simultaneously at different counters. So both the EVM and SVM are paving parallel roads to the future of blockchain. Ethereum's EVM has been the foundation of decentralized development, trusted and widely adopted. Solana's SVM, with its speed and parallelism, challenges that dominance, offering a powerful alternative for projects that need scale and speed. As the blockchain world evolves, developers and projects will choose the virtual machine that best fits their needs. The question is, will it be the tried and tested EVM or the lightning-fast SVM? Thank you for your time today. Hope you were able to understand this. Please like and subscribe to our channel and hit the bell icon for more in-depth tech breakdowns.